So a little HL extension topic on the electrolysis of molten ionic compounds is actually calculating amounts of products that are formed during electrolysis. The first important concept here is the mole ratio between the electrons and the actual product. So depending on the charge of the ion in the molten ionic compound, as well as whether or not it forms a monatomic for a metal or a diatomic molecule for the nonmetals, that's going to affect the mole ratio between the electrons and the moles of product. So as an example here with 4 different ions, a sodium ion only takes 1 electron to reduce it to sodium metal. So that's a 1-to-1 ratio between electrons and sodium. A copper 2+ ion takes 2 electrons. To form chlorine, it actually takes 2 electrons because chloride ions, although they're 1-, you need 2 of them in order to form the 1 mole of the chlorine gas. So to form 1 mole of chlorine gas, you need 2 electrons to be lost, 2 moles of electrons. And to form 1 mole of oxygen, again, it's diatomic, so it takes twice as many electrons as you would expect. So 4 moles of electrons to form 1 mole of oxygen. So for the same 4 moles of electrons, if we sent 4 moles of electrons through an electrolysis setup, we would expect to produce 1 mole of oxygen, 2 moles of chlorine, 2 moles of copper, and 4 moles of sodium if we applied those mole ratios. So you're applying mole ratios just like you did in the stoichiometry unit, but now it's a mole ratio of electrons to a particular product. So that's the first step. The other step is where do you actually determine how many electrons you sent through your electrolysis setup. In order to calculate that, you actually need to know a little bit of physics, and unfortunately this equation is not in the chemistry data booklet. I feel it should be, but it's not there, so you're going to have to remember it. So in physics, if you want to calculate the amount of charge that has run through a circuit in a given amount of time, you need to know the current, which is the rate at which the electricity is flowing. That has the unit of amperes or amps, the symbol is A, and you need to know the time in seconds. And if you multiply the current times the time in seconds, you will know the amount of charge in the unit of coulombs. Coulombs is like the electrician's mole. It's a very large number of charges. We don't use coulombs really in chemistry, so to convert coulombs to moles, we need to use what's called Faradays constant. This constant is in the data booklet, and it tells you the number of coulombs per mole. So if we want to know the moles of electrons that have traveled through our circuit, we need to take the current times the time, and then divide it by Faraday's constant, which will convert it from being a value in coulombs to being a value in moles. And once we have the moles, then we can apply the mole ratio and solve the rest of the problem. So there's basically 3 steps, just like in our standard stoichiometry questions. The first step is figure out the moles of electrons. You'll do that with current, time in seconds, and Faraday's constant, I times T divided by F. Second step is apply the mole ratio like we've done many times before. And the third step, if specified, would be to convert the moles of product into something like mass or into something like volume, depending on what the question asks for, and that would be normal stoichiometry steps. So clearly, different values affect how much product you are going to produce. This is a common paper 1 question. The identity of the product has a big effect on how much you're going to produce in electrolysis, and really the higher the ratio of electrons needed, then the less product is going to be formed for a given amount of electrons. So it's actually an inverse relationship. If we look back up here, oxygen, for the same 4 moles of electrons, we would produce the least amount of oxygen, and we would produce the most sodium. So if you look at the mole ratio between the electrons and the product, the higher that ratio is for electrons, the less product you are going to make. So with the same amount of electrons, you make half the copper as you do oxygen, because it takes twice as many moles of electrons to make oxygen as to make copper. So that's the first thing. The identity of the product has a major impact on the amount of product that gets formed with a given amount of electricity. The other values will increase the amount of product, and that's the current and the time, and they both have a directly proportional relationship with the amount of product. If you double the current, then the rate of electricity is twice as high, therefore you'll produce twice as much product in the same amount of time. And if you double the time, then at the same current, you will send through twice as many electrons because you're running it for twice as long. So you'll also double the amount of product. If you doubled both the current and the time, then you would expect to make 4 times as much product. So different factors affect the amount of product produced. To see a specific example, like a stoichiometry example, here it is right here. So you've got an electrolytic cell, contains molten copper 2 chloride, CuCl2, and it's run with a current of 1.5 amps for 2 minutes. First step, calculate the moles of electrons. So that's current times time divided by Faraday's constant. 1.5 amps times 120 seconds, so convert the minutes to seconds, divided by Faraday's constant gives us 0.0019 moles of electrons. Step 2, apply the mole ratio. So you should be able to figure out that because it's a copper 2 plus ion, it would take 2 electrons to turn it into copper, the element, and that's what would happen in electrolysis. So it's a 2-to-1 ratio, 2 moles of electrons for every 1 mole of copper formed. That means the moles of copper formed in this amount of time is 0.00095 moles of copper. And if the question wanted the mass of copper produced, you simply take the moles times the molar mass from the periodic table. And that means that in those 2 minutes, you would make 0.06 grams of copper. So in the end, it's really just a stoichiometry application on electrolysis. The new thing is using the current and the time and Faraday's constant in order to get the moles of electrons. And on a conceptual basis, you should know how current, time, and the charge of the ion or the identity of the product affects how much product is formed.